like what you're seeing there visually happening, if you had to put that into words, what would the words say here? Anybody? Yes?
I could be wrong, but it's like it doesn't matter the order of what you add in.
Yeah. So it doesn't matter the order in which you add. That would be kind of the words that I would say, right? Order. Okay, that's kind of what I see. Okay, what about the associative property? This is like a spin. I would think this is kind of like a spin-off of this like commutative property. Yes?
It doesn't matter which ones you add first together.
Yeah. So that, like again, I think it's again kind of like order doesn't necessarily matter, but when you have multiple things like more than two, I think you can choose to add any two together first that you want and then add the third. That's kind of what that's saying. Okay? You're going to get the same result. Does that make sense? It's kind of order doesn't matter, I suppose it's the same kind of wording, right? What about adding 0? If you add 0, nothing changes, right? So that's a relatively straightforward one. Now, what about something like this? If I just give you a problem, like compute. What's going to happen? There's like, I think there's a smart way to do this and a more difficult, well, I shouldn't say smart. Difficult and less difficult way to do this. How many of you want to go like this? Add these 3 up, add those 3 up. Why not?
Because 51 plus 49 is 100. You just multiply that by 3.
Okay, you could do that. Yeah. So okay, so let's talk about that. So if we group, because I'm trying to like group these things, right? I could group a 51 with a 49, which we know would be 100. And then how many of those groups could you create? 3, right? So 3 times 100, this should equal 300. Okay. They're not always going to be nice numbers like that, but anyway, that's that. Or you could do like, you don't even have to recognize that there's 3 groups. You could just say, okay, I know that there another one here, 51 and 49 makes another 100, and 51 and 49 makes another 100. So that's a total of 100, 200, 300. Okay. All right. What about this one? Let's use that same sort of strategy. What are we allowed to do? Do you want to do this bracket and then add this bracket? You can. Do you have to do it that way? Is that the smartest way? Again, what we're trying to do is like, I want you to take the, like I think when you tackle math, like you could do the approach that like, you could just do it with a calculator, no problem, fine, right? But then you've also got to have the perspective or the lens to come at a problem without the use of a calculator, right? And so how could you manipulate what you see there to make it easier on yourself so that you don't need a calculator? Is there any way to change up what you see, the way that it's written? Yeah, for the second problem, yeah.
7 plus 7 is 14, so 34 and 24.
7 and 7. Oops, I'm on eraser. So we're saying 7 plus 7 plus what?
I was saying that 7 plus 7 is 14, so
Yeah.
we just break the first bracket up into 2 sections and do 24 and 34.
Okay. 24 and 30. Is it 30? Is it 34 or 44? Be 14 from the 2 sevens, right? And what's 7 and 27? Is that 44? Is that what you're saying? Yeah.
I did 7 plus 17.
Oh, I see. Okay, so what I guess my point is, there are all sorts of ways to do this. Okay, what's another way that I think maybe is like, and you're thinking of in terms of base 10s, right? If you guys know that terminology, yes.
So, or you can also do the predecessors of 3 because
That's what I'm seeing. 7 and 13, 7 and 13, 3 with the 7, 3 with the 7. That's what I'm seeing. Okay, and I would say, okay, well, let's rewrite the line, and we'll group things accordingly, and then just run through it, right? So we'll say, okay, well, 7. Why you don't? It could be the 7. What do we say? 7 and 13. That's right. Okay, so we could go 7 plus 13. That takes care of those two, and then plus another 7 and 13, right? And then 17 and 3. And then 27 and 3. And I know each one, I've done this strategically, that each one of these clumps turns into a 10. So what's the answer? Or sorry, not a 10, but a base 10. Yeah. Yeah, so we're gonna see 20 here, plus another 20, plus 20, plus, oops, 30. Okay. Is it 80? The close. That's all right. It's all right. This is one of the, you'll see me make, like, you'll see me do this a number of times. We make one of these, like, you just make a mental math error. It's not my strong point. It's 20 and 20, you make 40, and then there's a 50 here. All right, so you can get a 90. Okay? The addition subtraction one's kind of nice. That's like a nice entry point for everybody. The multiplication division's a little harder. When we start asking you to multiply a string of, like, 5 or 6 numbers together, that gets harder. Okay? Or dividing. So this is a nice spot to start. Okay? This one's a little trickier too. You guys want to have a sec to work on this one on your own? See if you can come up with an answer. Do we know what the plus dot 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 plus is, first off? It means you gotta fill in everything from 4 to 18. So plus 5, plus 6, plus 7, plus 8, plus 9, plus 10, so on and so on, all the way up to 18. It's a little trickier. This one I'm particularly interested in what people do. So it's okay to take your time on this one. So I think we're going to see a whole bunch of different stuff. So I think maybe some of you jump right to this. I don't know. If you're still working, you're still working. That's all right. Okay. I think maybe this part might not be too bad. But I think you might start, as you get bigger numbers, I think you might start getting a little bit lost. Not lost, but just like you could make an error. So can I push everybody into, well, I'll let you keep working, I guess. I'm seeing a couple different, just in my close proximity, I'm seeing a couple different things. Okay, I would think like most people probably have this. Do we know what the sum of all that is? The left side? 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Do we know what the sum of that is? I'm just playing around, right? Like I'm seeing, here's something I'm seeing. Colton, do you want to say it? It's Colton, right? Colson. Sorry, buddy. Yeah, what do you got?
The sum of those 9 numbers are 45.
Okay. Do we have a little, do we have any I just saw this right now. Like, again, it's like a weak point of myself that I'm fully admitting to is this mental math or little tricks. I just don't know some tricks sometimes. Yes. Cole, so why don't we let somebody else have a go here? Yeah.
What I did is I did 1 plus 19 and then 2 plus
Okay.
19,
Okay.
and then basically it all adds up to 20, and then all of them are 20. You add all the 20s, and then 10 plus 20.
Okay. So great approach. That might actually be faster than the one I was thinking of because I didn't see that. What I was going to point out to everybody, and I won't necessarily do this, but I was going to point this out. 1 and 9 makes 10. 2 and 8 makes 10, 3 and 7 makes 10, 4 and 6 makes 10, 45. Okay, so that would be my quick way to do that one. Now, the reason why I pushed, or I'm not necessarily thinking of the way you did it, is because I wanted to lead us into something for later. And I showed some of you this last week on the snow days. And we're going to use this in our multiplication lesson. You guys ever broken a number down before? So something like 11. How could I break 11 down? I could go 10 and 1. Does everybody agree? And then, so this is why I was kind of blocked out from seeing your approach in the first place, because I wanted you to see this dissection, or we call this in later years you'll call this something kind of like decomposition, which I think that's what we called it last week too. So 10 and 2 and so on, 10 and 3, so on and so on, so on, so on, so on. Okay, we're going to use that this afternoon. I just wanted you to see that. Is that the best way to do this? No. We just found one that was better, right? If we look at, we'll get rid of all this, right? If I look, 1 and 19 will make 20, 2 and 18 makes 20, 3 and 17, 4 and 16, 5 and 15, so on, so on, so on, right? Did we see how these are all adding to 20? Okay. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9 20s. And then plus what? That little lonesome 10 up there, right? Is that okay, Aaron? Yeah?
You also have the 20.
Oh, yeah. Oh, I missed the 20. Sorry. I missed the 20. Sorry. Okay. So we get the 9 times 20 plus 20 plus 10. Is everybody okay? Might be the fastest. I don't know if that's the fastest way or not. But somebody could impress me and do it faster. I don't know. Okay. So 9 times 20 would be 180. Plus the 20 makes 200 plus 10, right? Everybody okay? Anybody else have a different way of doing it? Faster, that one? I don't know. I'm curious. Yes, Aaron?
Well, I did the first number and this last number. Add those two together, which is 1 plus 20, which is 21.
Okay.
And then I did 20 divided by 2 to see how many groups you can do of those.
Sorry, so
21.
Sorry, 1 and 20 makes 21, and then what did you do next?
I did 20 divided by 2, which gets 10. So you have 10 groups that make 21.
Okay, that's good too. Yeah.
And then I did
Yeah. So then you took the number of groups that you would have had, the 20 divided by 2, and multiplied by that, you get 210, right? That's quite fast too, if you know that. Okay. Is everybody happy? These are tricks. I wish I was better at finding some of these tricks myself, because it would make life a little easier. You imagine having to sit there 1 plus 2 plus 3, you typing that in the calculator, a waste of time, right? They can math, even down to the most basic level of addition and subtraction. Being able to do that stuff in your head saves you time instead of having to type it in the calculator, right? Okay, so you'll find the recurring theme with math is we try to teach you, although there are ways to do it that you're most familiar with, I think the theme as you go through high school is we're trying to teach you the most efficient way to do something, okay? And so if you ever question, why is it I'm doing it this way if I can do it this way, it's probably because it's a little easier, not easier, faster to do it the way we're trying to show you. In my experience in going back to high school math and learning it all over again. Okay. So now we have this concept of negation, okay? The negation of a number of a is written as negative a, and it satisfies the property such that negative a plus a is equal to 0. Do we have, this is an important concept that we will revisit later. Have we ever seen this before in some capacity? Do we know what we would call this? Negative a plus a equals 0. Do we know what we call that in your endeavors in the past? We're going to revisit this later, okay? But this is like, you can kind of put a star beside this and say we're going to call this like the creation of 0 pairs. Have you ever heard that before? Particularly 0 pairs. Okay, when you take a negative a and add it to an a, that's like that nets out to be a 0. That's what we call a 0 pair, and we're going to use that to our advantage later when we actually start solving equations. Okay, you'll hear me say that a number of times. 0 pair, 0 pair, 0 pair. Okay, and I'll teach you what that actually looks like when we're solving equations. Okay, so the negation, this is relatively straightforward. The negation of 4 is going to be negative 4, negative 3, negative 2, negative 1. You have a negative 0. Does that make sense? No. Okay. Doesn't make sense. Why would you write that? 0. No, here's the catch here, though. What's the negation of negative 1? Colson?
Positive 1.
Positive 1. Well, I suppose you could rewrite this as being negative 1, and you're going to make negative 1 positive. Sorry. You're going to make negative 1 negative. And what did we say yesterday about a plus sign? How many sticks are in a plus sign? 2. When I draw a plus sign on my page, there's 2 sticks. I just made this up on the fly, right? 2 sticks create a plus sign. We have a positive 1. Okay, same thing. Well, for the next one, the negation of negative 2 would be positive 2. Okay. Now, just for your reference, because I know this comes up in a lot of kids ask this question. Is there another way to write all of those? Is that a curiosity? Can we all see that okay? Yeah. Is there another way to write those? Is that a curiosity? Okay. That'll come into play later. Or like, is there anything wrong with taking a number like something like this, 4, and multiplying it by 1? Does that change the result? That'll come into play later. We'll see that something like we have just an x. What's the coefficient? Do we know what the word coefficient means? No? It's whatever's out front of the variable. Okay. What's out front of the variable? Is it a 0? What happens if I put a 0 here? 0 times x is what? 0. So it can't be a 0. And that's a common misconception that a lot of kids see. They're like, oh, there's nothing there, so it must be 0. Well, 0 times anything is 0. So that means if you don't see anything there, it's a 1. It's just presumed to be a 1. Okay? Otherwise, it'll specify what's there. 2, 3, negative 1, negative 2, whatever. Right? We'll see that later. Okay, so we're going to see here, this is a positive a. Okay. You guys want a sec to work on this? See how you make out? Do we know what the little dots are in the middle? I mean, you could maybe inference because you see the result on the other side of the equal sign, but what are we seeing? If you had to take a guess at what that dot meant. Aaron, yeah?
It's the multiplication symbol.
Yeah, so it's multiplying. There's all sorts of ways you'll see as we go through here in the course. We're going to start moving away from this notion of 4 times 4. There's no x anymore. It could be the dot in the middle. That signifies, I don't think Miss Farahani likes the, when you type it in, especially in the IB, and she just talked about this, which is why it's on my head. for like your IB exams or like some of the stuff that you're going to do in grade 11, 12, she does not like seeing the asterisks for multiplication in your like written report stuff. So I wouldn't use that. I would write it as like 4.4, like what's there, or put it in brackets. Okay? Is everybody okay? If you don't put, obviously you can't do this because that looks like 44. Okay? Can't do that. Right? So any of the first two would be acceptable, I suppose. Okay? Do you guys want to have a go here and see what the pattern is? Or figure out what the last blank? Do we know what the last blank is? Try to curious? Yeah? It'd be -4, okay. And then, so that's good that we're able to identify that. Now you're looking for a pattern in those numbers. So what sort of like pattern do you see in the outputs there? So when I say outputs, I'm looking here. 16, 12, 8, 4, 0, -4. What, do you see it? Do you recognize any sort of pattern there? Venus?
If both numbers are positive or both are negative, then the result will be positive. But if they're different, then it'll be negative.
Okay, I was processing the first statement. So let's go through that. If the two numbers are both positive or negative, and you subtract and do what to them? Sorry?
Multiply them.
Or multiply them. I see. Of course it's multiply. That's what we're doing. And they'll come out to be positive. Is that what you're saying?
Yes.
Okay, good. Okay, so that's a general rule, I think. Allie, what was yours?
I was going to say something.
Same thing? Okay, that's actually not the one I'm looking for, but I'll write it down because that's a good recognition. So if, we don't want to write in highlighter. If the two numbers or negative, the result will be when multiplying. Does that sum up what you guys were thinking?
Yes.
Okay. Okay, that's one. Not this. God. Okay, I saw another hit. Yes.
It's going down by 4.
Okay. That's what I'm looking for. Not that I was right or wrong. Both those were good. Okay, those are both good patterns. The one that I saw, because I know where we're going with this course, is this. From 16 to 12, that's a difference of 4. 12 to 8, it's a difference of 4. 8 to 4, that's 4. 4 to 0 is 4. That's a difference of 4 as well. So we agree? That actually forms a big foundation of your grade 9 course without you knowing it, which is why that's the one my eyes went to. Okay? Sometimes as a teacher, like I know where we're going, I lose sight of, and that's why I ask you guys so many guiding questions to see what you get out of it, right? See what you're thinking. Because I know where we're going. It's hard for me to come out of that, like, almost have beta blockers on in terms of, like, other possibilities, right? So that's why I ask those questions. Okay? What's that pattern suggesting? I actually don't know what to write here. What do you think?
I was wondering what the wording was going to be as well. I think that's the takeaway.
The decreasing pattern, I'm thinking in my head, right? I think the pattern's decreasing, right? Does anybody else have any thoughts on that? This isn't my sheet, so this is the first time I'm going through this. But if I was me, I would say this is a decreasing pattern, right? right here. Oh, just the rearrangement of it? Okay. That's what I was thinking. Okay. So we could also, using what we've done already, what's another way to rewrite this? Sorry, I'm now on to the subtraction division different. Does anybody have any questions with the above part? We can go on. Okay. What's another way we can write this right here? Yes?
Negative b plus a.
That's good. Because what did we say earlier? The order doesn't matter. You can mix in the subtraction. The order doesn't matter. Right? You'll get the same result if you did. And we can test this with numbers. You guys can always test these with numbers too, right?
Do you have the truth tables?
There's some on the... I don't know how many of them there are, but there are some there.
I just need one or two left.
Okay, yeah, there's some there. So the order doesn't matter, right? So why do we care about that? Well, sometimes it might be easier to do something like all our brains are going to operate differently, right? And so again, we're going to come back to this theme of not needing a calculator. Okay, so that's why we're trying to do this, is to show you how to write particular things in different orders that are perfectly valid so that you can do it in your head a little bit easier. There might be examples where, like for instance, this one here is not too bad. Like I think we all know 11 take away 3. We know that to be 8. But let's say we had a question where it called for you to flip these around. It might be a little easier. For instance, what if I said negative 3 plus 11? Like let's say that was the question originally. Would you all agree that that's maybe a little tougher for no real reason? I'm not saying it's really, really hard. I'm just saying, is it tougher than 11 take away 3? In my head, I think it's tougher, right? So what I'm saying is, if there's an instance where this is the original question, then why wouldn't you just flip these around to be 11 minus 3? Again, I want you to operate under like, how could I do this without a calculator? That's like the whole point of this. Okay. Okay. Any questions? You guys want to have a go at the problem 5? Well, I guess we're almost done, so I can guide you through this and then I can give you some time to work on the questions. Okay. Do we have any questions so far? I promise it'll get a little bit harder if some of you are sitting there twirling your thumbs. It'll get harder. Remember, like, you all come from different, like what I was saying yesterday, you all come from all sorts of different places. Different elementary schools, different programming. Some of you come from like Challenge or Leap, or like some of you just come from regular programming. Like, you're all over the place. And what I found in the past, I think one of my biggest strengths as a teacher is to meet everybody where they're at and build your skills up. That's my job. It's not to teach to the top 10%, not to teach to the bottom 10%. It's to teach to everybody. And I found like a recurring theme for me in the courses that I've taught in the last like 2 years is we always move slow at the beginning to move fast by the end. Does that seem fair? Valid? Okay, and I do that. It doesn't matter if it's grade 9, grade 10, 11, whatever. I meet the kids where they're at, and then we just build up, just see how far we can get. And you'll find everybody can benefit from some of the lower end stuff, I think, sometimes. Might not be right now, might be later in a different concept. But I think this theme of like building on slow and getting faster and faster, that helps everybody, okay? So, let's go. What's this? What would you do here? Do you want to deal with 2 negatives? I don't want to deal with 2 negatives. What do 2 negatives make? A positive. That's what I would want to deal with, right? So why don't you go 12 plus 7? What is 12 plus 7? Also, don't forget your equal signs. I'm getting better at explaining that, but don't forget equal signs. I think in your IB program, they're very, very strict. Again, like this is my first like taste of what IB's like, teaching-wise. But I think by grade 11, 12, they are very, very strict. Like, I think they have a whole marking system for like format and like formality stuff, like equal signs and like labeling X, Y axes and things like that. There's a whole chunk of your test that's dedicated to that. So you got to remember, like, just follow form, and I'll try to model that as best I can. Okay, but equal signs is a big one. Okay, if you write something, you got to carry it down. Okay, you got to tell me it's equal. Okay, so what's 12 plus 7? 19. Yeah. Okay. Are we happy? All right. Does anybody want to flip the order of this one, or just do it as is? Yeah?
Well, you could flip it to negative 13 plus 11.
Okay. Or you could just do 11 minus 13. Either or will work. Okay. Right. What's the result? Negative 2. Okay. What do we want to do here? Again, I don't like this. Bothers my eyes. I don't like that. Well, I think that's most of the time that's the first thing I get rid of is that double negative. A minus a negative kind of hurts my head to think about. So I just turn it into a positive. So you can rewrite the line. 12. What about here? Well, I'll go minus 11 plus 6 plus 15. Does everybody agree? This one's not too bad. 12 minus 11. What's 12 minus 11? That'd just be 1 plus 6 plus 15. Okay, what's that? 7 and 15. Yes?
22.
Hey, there you go. I beat you though. Colson, yeah, bye.
And I was also going to say it could be sort of read a different way as 12 plus negative 11 minus negative 6 plus 15.
Say that again.
12 plus negative 11 minus negative 6 plus 15.
12 minus 11. Isn't that what's there? Oh, I see. Instead of turning this here, just leaving as the two negatives. Is that what you're saying?
Yeah.
Yeah, you could do that too. Yeah, it's not everybody's gonna have the same approach, right? And that, like, just because I choose to flip it, that just fits my head, right? And I don't like the double negative thing. If you like the double negative thing, go for it. The important part is that there are multiple ways to do all these questions. And I think this lesson is a perfect opportunity to do that in a very, very simplistic way, is to illustrate that there are multiple ways to do all sorts of math questions. And it's perfectly fine. You're all going to bring your own strengths and weaknesses to math, right? I think your goal should be to, like, further develop your strengths and also work on your weaknesses, right? So whatever that looks like in whatever topic that we're working on, that should be the goal, right? Why does he do this? There's some hard ones in here. The big ones. All right. What are you going to do here? Yeah. Colson, what do you got?
I think this connects to the problem 270 plus 17 plus 27 and so on.
Fair enough. It very well. Yeah, very well.
I noticed that 268 is close-ish to 168, 1375 and 1275, and negative 6179 to negative 6.
Oh, okay. All right. So as everybody here catching what Colson's putting down here, we're saying we're gonna try and, like, group these things according to similarities. That's clever. See? I miss these things sometimes. Do we want to deal with the two negatives? I think I'm going to deal with the two negatives too, just to save everybody the hassle. Okay? So let's rewrite this thing, and we'll just start grouping things together that look the same. Okay, or similar, something that we can do easier, right? I think looking at this, that freaks me out right off the bat. When you start looking at it a little longer, you're like, okay, it's not so bad, right? If I were to, like, play around with it. So if I went 268, take away 168, plus 1375, take away 1275. Two negatives make a plus. Plus 6,179. That's an 8. Take away 6,079. I'll move that over so we can save some room for the next question. Okay? 268, take away 168. That sounds like 100 to me. 1375, take away 1275. Also sounds like 100 to me. 6,179, take away 6,079. Also sounds like 100. 300s make a 300. Okay, last one. 2 negatives make a positive. We have positive 7 plus 9 plus 5. What's that?
21.
There you go. Again, that's good at blackjack. Don't forget your equal sides. I'm running out of room here. Right? There you go. In case some of you weren't familiar with the game blackjack. Questions, comments, concerns? We all right? There's a whole bunch of questions there for you to try. What time is it? Break time? Break time. Okay? Here's typically what will happen.